In this problem, we're asked to find all of the solutions in degrees, you can see that by theta, in the domain 0 to 360. So before I look too far into this on how to do it algebraically, I graphed the left side, which turns out to just be a sinusoid, and graphed the line y equals 0.4, and so I can see between 0 and 360 that I expect to have 1, 2, 3, 4 different solutions that we're looking for. So again, it's always a good idea to figure out how many answers you need so you know when you're done with the problem. So when we look at solving this algebraically, I have two different cosines, two different sines. As of right now, I can't use any Pythagorean identities. I can't factor anything out. But if you review the sum and difference properties, or the composite argument properties, we can find a pattern, and so we can replace it with a single cosine or single sine function, depending on the property. And so notice that this goes cosine, cosine, sine, sine, and we're adding them together. So looking at the properties, cosine, cosine, sine, sine, separated by a plus sign, I can take the cosine of the first angle minus the second angle. And so I'm going to use that property and rewrite the left side as the cosine of 5 theta minus 3 theta. And this then equals 0.4. I can then combine these to where it's cosine of 2 theta equals 0.4, which then makes it an equation that is solvable for us. And so thinking about where cosine equals a positive ratio, that will be in the first and the fourth quadrant. And so in degree mode, I'm going to take the cosine inverse of 0.4, and that will give me one answer, which ends up being 66.42 degrees, which means that my other answer would be negative 66.42 degrees. And we're not looking for what angle would make cosine 0.4. We're looking for what angle times 2. And so I'm going to have to take both of these answers and divide them by 2. So before I do that, I'm going to go ahead and set the inside equal to 66.42. And remember, this is approximately equal to. But to find more answers, I would add 360n. So usually that'd be my general solution, as well as negative 66.42 plus 360n. However, since this isn't just a theta, this is a 2 theta, I need to divide both of these answers by 2, which will then divide my periods both by 2. And so my period is no longer 360, it's actually 180. And you'll verify that when you solve for theta here. So I'm going to take that 66.42, divide by 2, and we end up getting about 33.21. And now I'd run a 211 plus 180n. Theta would then equal negative 33.211 degrees plus 180n. So I found 2 of the answers. Nope, scratch that. I found 1 of the answers because my domain doesn't want negative solutions. So I'm going to go ahead and start with this positive one and add 180. And so I get 213. That's going to be another solution. And you could add 180 one more time, but note that we're going to go past that 360. So if I add 180 once, I end up getting another solution, which is the 213.211 degrees. So this would be an answer as well as this 213. This is not an answer, so I'm going to have to add 180 to it once. So again, use the entire answer in your calculator, not your rounded answer. So now the negative of that angle plus 180. That'll give me the 146 plus 180 again. And that is still below 360. So my first answer from this general solution is the 146.789 degrees. And we could add 180 again. And we would get 326.789 9 degrees. So again, this is not an answer, but it did get me to my other two answers. Now that we've found all 4 solutions, we know that we're done.